All right, yesterday we did 5-1, day 1, and we talked about types of triangles. We talked about how to determine what type of triangle we had. We can identify it based off its angles or its sides. And today we're going to talk about some parts of a triangle, mainly its angles, and how to find the different angles within a triangle, both inside or outside of the triangle. Interior angles, as you can see here, interior, pretty straightforward, right? Interior angles are the angles on the inside of a triangle, okay? And there's 3 of them. And what do we know about the 3 angles on the inside of a triangle?
They equal 180.
They equal 180, okay? That's something that we've talked about. And so that's the first theorem right here. We've already seen that before. We know the 3 angles inside of a triangle add up to be 180. We call that the triangle sum theorem, okay? Not anything different than what we've seen before. The exterior angles, in this case, we got 3 of them, okay? And they're marked in blue up there. They're formed, and they're right next to the interior angle. So like right here, this is the interior angle. The angle right next to it is exterior, right? So you're extending a side, essentially. And if I had these two together would make 180, right? Because they make a line. And what the other thing that's going to hold true here as well is the 2 remote interior angles, in this case A and B. If we added these 2 together, it's going to add up to equal this outside angle, okay? The reason why is because, let's do an example here. Let's say I put this as 40 degrees right here. Okay? If I said this is 40, what would the angle right next to it have to be?
50.
This one right here. These 2 together would make?
90.
They make a
Oh.
line, right? So it'd have to be 180, okay? 140. Yep, this would have to be 140. Okay, these 2 together make a line, right? And so this angle here would have to be 140. These 2 angles here, because these 3 angles together make 180, these 2 also have to add up to be 140. So there's a lot of different combinations that could make that work. Maybe this is maybe this one's also 40, and maybe this one is, we don't want to do 40. Maybe this one is 60, and this one is 80, okay? These 2 together are going to add up to equal this. So we call these 2 the 2 remote interior angles because they're the furthest away from the exterior angle that we're talking about. And that's the exterior angle theorem. These 2 angles together add up to equal angle 1 because angle 1's the furthest away from those 2. And so those are the 2 theorems that we're going to use over and over again today. Triangle sum theorem, the 3 angles inside of a triangle add up to be 180. The 2 remote interior angles add together to equal the exterior angle furthest away from them. Okay, so let's look at this one down here, first of all, on the left. These angles are all on the inside of the triangle, right? So on the inside of the triangle, what are those triangles going to add up to be, or those angles going to add up to be? We're going to do 48 plus 34 plus something equals 180. And that's what my equation would look like, okay? Do you have to write an equation out? I mean, not necessarily, but this is what we're doing, right? And so then to get x by itself, we just got to subtract 48, we got to subtract 34, and what are we left over with? 98. Okay, so x is 98. That's our answer. Okay, the one on the right, not much different here. 55 plus 68 plus something has to add up to be 180. The 3 angles inside of a triangle must always add up to be 180 every time. Okay, And there's a couple different ways you could do this. You could subtract those two individually from 180. I could do 180 minus 55 and then and then whatever that is minus 68. Or I could add these two together and then subtract it. So what would 55 plus 68 be? How much? 123, yep. And then I could subtract 123 from 180. And that gives me 57 is left over. Okay, but if you wanted to subtract these two individually from 180, that would be okay too. Okay, so there's a couple different ways that you could go about doing that one. Okay, these are going to be a little bit more work. Number one of the angles on the outside of the triangle. Secondly, we've got some variables going on in here. Okay, and so they're asking us to find J, K, M. And so we've got to really pay attention to what it's asking us to find. It's not, and in some cases it may say find X, right? We've seen problems like this all throughout the year so far. Sometimes it'll say find X, sometimes it'll say find the angle or the side length or whatever it is. In this case, we're looking for angle JKM. Angle JKM is this big angle on the outside here. But what I'm going to have to do first is I'm going to have to find out what the value of X is, because I can't find this angle without knowing what X is, because all we know is that JKM is 2X minus 5. Okay, so the relationship that we said between these two angles and this angle is these two angles added together will equal my exterior angle. I do not need to find this guy right here. Okay, it has nothing to do with the problem. And because I don't know the actual angle measures, I can't do it anyway. Okay, so X plus 70 equals the exterior angle, which is 2X minus 5. Hey, we got to find X first. Even though I know it doesn't say to find X, we have to know what X is before we can find the angle. We're gonna use X to find that angle. So now it's just solving a basic old equation. We got to subtract X from both sides. We got to add 5 to the other side. We get X equals 75. And sometimes we may just stop right there, but you have to read your directions carefully. In this case, it wants to know what is JKM. What is JKM's expression equal to? What's JKM labeled as? How much? Here's JKM. What's the expression for JKM? Well, it is an obtuse angle, but what's the expression? What is it labeled as? What's inside of JKM? Here's JKM. It's just 2X minus 5, right? That's the expression, right? Yeah. And do we know what X is? Yeah. So all we got to do, we know that JKM is 2X minus 5. So we're going to do 2 times 75 minus 5. So we would say angle JKM is 145 degrees. Okay, pay attention to where the angles are at. So on this one here, where is 5x minus 10? Inside or outside the triangle? It's outside, okay? These two are inside the triangle, okay? We don't know angle 1. That's what we're trying to find. Do I know what x is? No. So we got to find x. And using what we have given to us, I can't just subtract these from 180 like I did on the first couple problems on the other page, because I don't know what x is. So I got to find x first. So you got to use what we know, and we got to be able to find out what x is. Logan. All right, so what do we know about these two expressions, 3x and 40? What are we going to do here? What's my equation going to look like?
3x plus 40 plus 5x minus 10.
Perfect, good. 3x plus 40, because those two are on the inside. We're going to add the two remote interior angles, the two interior angles that are the furthest away from 5x minus 10, equals 5x minus 10. And then we're going to solve, okay? So we got to get our x's on the same side. I kind of combined two steps into one here. So I'm going to bring the x's over here. And then we divide by 2. All right, so once again, it does not say find x. So we have to find what the measure of angle 1 is. Angle 1 does not have an expression. So I have to find another angle that I can use to help me find angle 1. Okay, so what would be maybe the best option here? What do you guys think? Okay, do it up here. Yeah. So if I plug 25 in up here, then this angle is 75. Okay, and what do I know about the measures inside of the triangle? They're 180. Okay, and so I could do 180 minus 40 minus 75. What's that leave us with? 65. Okay. Angle 1 is 65 degrees. Okay, another way that I could have done it is I could take this and plug it in here, right? I could do 25 times 5, which is 125, minus 10 is 115, okay? And then I could subtract that from 180, because these two together should make 180. Okay, and so there's more than one way to kind of approach it, but we got to figure out one way to find that angle, okay? And there's not necessarily a right or a wrong way to do that. We've seen a couple of corollaries as we've gone throughout the year, and it's just kind of like an additional statement within that, what we did. And this kind of goes back to what we talked about yesterday. When I have a right triangle, these two angles must be what? Can A or B be an obtuse angle? No. That gives me too much, right? The angles can only add up to be 180. If I've already got a 90-degree angle, there's no way that these two can be obtuse. So what we're saying here is that when I have a right triangle, those two, not only do they have to be acute, but because I already have a 90-degree angle, what do these two angles have to add up to be? 90. Because I need a total of 180, right? I've already got 90 degrees here, so that means these two together must add up to be 90. So these two angles, angle A and angle B, must add up to be 90 degrees. They're complementary. Complementary means 90, okay? So it could be 30 and 60, 40 and 50, 20 and 70. There's all kinds of combinations they could be, but they have to add up to be 90. If they don't add up to be 90, then that means this angle over here can't be 90. But if this is 90, these two have to add up to be 90 to make a triangle. The reason why that's a little bit helpful is I don't necessarily need to use the 90-degree angle here. I don't need to add all three of those up to be 180, because the two leftover angles, I already know that I have a 90 down here. The two that are left over have to add up to be 90. I mean, if you want to, you can add all three of them and set it equal to 180. There's nothing wrong with that, but this is just a little bit simplified equation. We don't need to add it up to be 180. Hey, and I will tell you this, be careful here, because this is one of the most common mistakes that I'll see. And it goes back to our algebra days. When I have 2x and 1x on the same side, what am I going to do here? Add them, right? It's just combining like terms. Do not subtract x from 2x, because it's not on the opposite side of the equation. 2x and 1x are on the same side of the equal sign, right? I feel like you guys are all like in a daze today. What's going on today? Everybody's just kind of like in their own little world right now. As I look at this, they're on the same side, right? So 2x and 1x makes 3x. 3x minus 6 equals 90, not 96. Got a step ahead of myself. We're combining like terms. We're not moving it over, okay? And now I'm going to add 6. And then I'm going to divide by 3. Okay, it does not say find x. Sometimes it'll say find x and we'll be done. This one does not. This one says find the measure of the two angles. Okay, so the first one is 2x. We now know that x is really 32. So this is really 2 times 32, which is 64. My other one is x minus 6. So it's 32 minus 6, which is 26 degrees. Hey, how could I check my answer here to make sure that it is correct? They have to add up to be 90. The 64 plus 26 make 90. If it doesn't, then I've done something wrong, okay? And so that is a good way that you can always make sure that your answer works. Okay, this one here does not have a picture. Can you do it with or without a picture? Sure. Okay. Does a picture help? Probably for some of us it would. Okay. So if you're a visual person, I know I've said this a lot as well. If you're a visual person especially, draw yourself a picture. Some of you, I know that seeing a picture is going to make this problem a whole lot easier. The doors of a new building are right triangles. For each door, the measure of the acute angle in the triangle is twice the measure of the other. So we already drew a right triangle. For each door, the measure of the acute angle is twice the measure of the other. Okay, so if I said this angle is x, then what's the measure of the other acute angle? What's an expression I could use if the first one's x? What's it tell me about? Yeah. 2x. Yeah, it's double, right? It's twice the measure. So this has to be 2x. And what do those two acute angles have to add up to be? 90. Okay? So 1x plus 2x equals 90. So that would be 3x equals 90. X equals 30. So 30 degrees is one of them. What's the other one going to be? 60. It's going to be twice that. 2 times bigger. 30 and 60 add up to be 90? Yeah, so it works. Could I do that one without a picture? Probably. Okay, but just labeling it and seeing the picture, I think, helps. Okay, to make this one a little bit easier, I'm going to label all the angles in this picture. I'm going to give you a minute or two. I want you to find the 8 angles in this picture that I have labeled. Using all the things that we've talked about the last couple days and even earlier in the semester. See if you can find all 8. I'm not sure I want to put that in my mouth, Ben. That sounds like a rock.
I know. Just tap on it. Just give him a roll. All right, sounds good job.
All right, one thing that I would tell you about these problems like this, we're going to see problems like this off and on throughout the year where I have like a bunch of angles that I got to find. Do I have to find angle 1 first, and then angle 2, and then angle 3? No, it's really just like a puzzle, right? I just got to find it and make it all work together, and then eventually I got to have all 8 angles at the end, okay? And so you don't have to go in order and think I got to find angle 1 first. I mean, if you want to find them in order, you can, but sometimes it's easier just to pick and choose the ones that you want to find first, okay? So, where do we want to start at? Ryan, what would be a good angle to start with? Okay, angle 1. How come?
Because you already have that 55, because you have the 35 and you have the 90, which means that must be equal to 1.
Okay, yep. So what would we get for angle 1? Did you get it? 55, yep. These 2 angles here must be supplementary, so they have to add up to be 90. So 90 minus 35 would be 55. Okay, good. Angle 1's good. What's another one? What would be an easy one once I know what angle 1 is? 3, right? What do we know about angle 1 and 3? They're congruent because what kind of angles are they? Vertical. They're right across from one another. Yep. 1 and 3 are vertical angles and they are congruent. So 3 would also be 55. What kind of relationship would 2 and 3 have? Supplementary. Good. So 180 minus 55. 125. And if angle 2 is 125, then what's angle 4 got to be? 125. Those are also vertical angles. Okay. Angle 7 should be a piece of cake, right? If this is 90, what's the one right next to it have to be? 90. Okay. Angle 8 should be a piece of cake, because if this is 35, how am I going to find angle 8? These two are what? Supplementary, right? They make a line. So 180 minus 35? 145. Okay, these two right here are the ones that we have left, okay? 5 and 6. I need one to find the other. I don't know either one of them right now. So what would be the easier one to find? 5, yep. Because 5 is on the inside of the triangle, okay? And what we could do here then is this, we know angle 3 is 55. So these two have to be supplementary. So 90 minus 55 would be 35. Okay, and if angle 5 is 35, there's two ways that you could find 6. I could do 180 minus 35, or these two added together should equal that as well, because these are the two interior angles that are the furthest away from it. So I could just do 90 plus 55, or I could do 180 minus 35. Either way, I should get 145. So there's lots of different ways that I could approach it. There's not necessarily a correct order that you have to go in, but our goal is to get all 8 pictures, or all 8 angles in the picture. Okay. That's it. That's day 2.